Probability. So probability is always a fraction. And so what the fraction is, so if we call an event E in a sample set S, so there's always going to be a finite sample set. So the number N, the number of the event happening, is divided by the number of the outcomes that are possible. So let's look at the number of outcomes possible. If we're picking a card from a deck of 52 cards, so there's 52 different outcomes. So an event would be like picking a black face card. So what do I have? The Jack, the Queen, and the King, right? And the spades and the club. So how many do I have? 6. So the probability that the chosen card is a black face card would be, 6 out of 52. So that would be the answer to the probability. So I'm just going very slowly. I'm sure you could get this quicker. All right. So a dice is tossed. One's blue and one's gray. And this is just to make sure that you're identifying the difference between, say, if I'm getting wanting a total of 6. So if I want a 1 and a 5, so this is the blue and this is the gray, then that would be different than a 5 and a 1 if this is the blue and this is the gray, right? So they're differences. All right, so then what other combinations can I get a sum of 6? So 2 and 4, 4 and 2, and then there's just where they're both 3. We're both 3, right? So this would be the event happening. So the number of them happening would be 5. And so then the probability that the sum of the numbers is 6 would be 5 out of the total. What's the total? Haven't done the total yet. Oops, that's not what I wanted here. I wanted the number in the N of E is 5, right? That's what this is. But the number in the sample set, so this has 6 and this has 6, so that would be 36. So 5 divided by 36. Okay, so let's just make sure we're good with the language. So probability that the sum of the on the pair of the dice is at least 9. That means 9 or more. So don't know any other way than just to write them all down, right? So if I get 9, so that's 3 and 6, or 6 and 3 on the different die. You could think of them as the blue and the gray if you want. 5, 4, 4, 5. Let's see, more than 9 would be 2 5s or 2 6s, right? I'm just kind of thinking of it in pairs. Then I've got 5 and 6 or 6 and 5. And so that's 11. And that's 9. I think I missed 10. So 4 and 6 and 6 and 4, right? So I see 10 here total out of a total of 36, right? So the number of the event happening and then over the total number in the sample space. All right, so 6 or at most 6 means 6 or less, right? So I'm just going to go for the simple ones, 1, 1, 2, 2, 3, 3 at first. And then I'm just going to think of all the combinations, right? And again, I don't know of any other way than to write them out. 1, 4, and let's see, 2, 3, 3, 2, 4, 2, and 2, 4, right? So this gives me 2, 4, 6, 8, 10, 13 out of the 52. So that's the probability that I'd have the sum of at most 6. Okay, so we want to be able to count the numbers in a list. So if I've got 2 numbers, M and N, then if I want to count the numbers in between, right, in the list, like here, these numbers here, I mean, this one I can just count them. I can see there's 5 of them. But how do we get that without going through and counting it? So we want to say take 9, subtract off 5, but then add 1, and then that will count 1, 2, 3, 4, 5 of them, right? Okay. So this is a little bit of a different question. So if the largest of 73 consecutive integers is 89, so we got something, question mark, dot, 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 up to 89, right? And I know I have 73 integers total that I've counted, right? So this would be 89, subtract, I'll just label this as x, right? minus x plus 1, that's 73, right? So then you can say 90 here, right? 90. And then subtract off 73, that's the beginning point. So 17 is where it started, right? So 17 to 89, that gives me 73 integers. So there's just going to be a reason for you to know how many are in a list. All right, so starting on counting. So probability is one thing, then counting, we're going to do much more in the realm of counting. So how many positive 3-digit integers are divisible by 5? Okay, so positive 3-digit integers. So we're starting at 100 and we're going all the way to 999. Okay, so let's list the multiples of 5. So 5 times 20 starts at 100. I get 5 times 21, dot, 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 dot. I can go all the way up to 5 times 199 because 5 times 200 gives me 1,000, and I don't want to go that far, right? I'm stopping there. Okay, so how do we count this many? So here I have 20, 21, dot, 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 all the way to 199, right? So I want to count how many numbers are there between 20 and 199. Well, that's what we just figured out how to do, right? Take 199, subtract off 20, add 1 to count all the numbers in between. So that's 180. So there's 180 multiples of 5 between 100 and 999. And so just adding a little more of a question here. What's the probability that a positive 3-digit integer is divisible by 5? So that would be 180 divided by, how many integers are there? Positive 3-digit integers between 100 and 999. Well, that's going to be 999 minus 100 plus 1. So that gives me 900.